Imagine you are standing inside an elevator that has just started moving upward. Now, 2 seconds after the elevator begins its upward motion, a small bolt suddenly falls from the ceiling. Here is the interesting part. The elevator is accelerating upward, but the bolt, once released, is in free fall under gravity. So, how will the bolt appear to move to an observer standing outside the elevator? The elevator has a floor-to-ceiling distance of 2.7 meters and is moving upward with a constant acceleration of 1.2 meters per second square. The bolt is released 2 seconds after the elevator starts ascending. Your challenge is to find two things. First, the time for which the bolt remains in free fall. And second, in the reference frame of the elevator shaft, determine the bolt's displacement and the total distance traveled during its free fall. This problem is a beautiful application of relative motion and understanding frames of reference. But don't watch the solution yet. Pause the video and try solving it yourself. Write your answer in the comments. And if you enjoy challenging physics problems like this, subscribe to Numericals Studio. Now watch the solution and match your steps with us. To solve this problem, we need to analyze the motion of the bolt from two different reference frames. First, the reference frame of the elevator. And second, the reference frame of the elevator shaft or the ground. But before we proceed, what exactly do we mean by an inertial frame and a non-inertial frame? For simplicity, you can think of an inertial frame as a non-accelerating frame, and a non-inertial frame as an accelerating frame. Now, let's first analyze the motion of the bolt from the elevator frame. The bolt is released from rest with respect to the observer inside the elevator. Therefore, the initial velocity of the bolt relative to the elevator is 0. Now, we need to calculate the acceleration of the bolt relative to the elevator. The relative acceleration is given by the acceleration of the bolt with respect to the ground minus the acceleration of the elevator with respect to the ground. Remember, the signs of the accelerations are extremely important. The bolt accelerates downward due to gravity, while the elevator accelerates upward with an acceleration of 1.2 meters per second squared. Therefore, relative to the elevator, the bolt accelerates downward with an acceleration equal to g plus a. Since this acceleration is constant, we can use the equation of motion. The bolt falls through the height of the elevator, which is 2.7 meters. Using the equation, S equals ut plus half at squared, and taking the initial velocity as 0. We can calculate the time taken by the bolt to reach the floor of the elevator. This gives us the free fall time of the bolt. Now, let's analyze the same motion from the ground frame. At the instant the bolt is released, it has the same velocity as the elevator. Why? Because just before release, the bolt is moving along with the elevator. So, from the ground frame, the bolt is initially moving upward. It continues to move upward, then reaches a maximum height, and finally comes back down to the floor of the elevator. This is the interesting part. The bolt does not simply fall straight downward when observed from the ground. It first moves upward, slows down due to gravity, comes to rest momentarily at its maximum height, and then starts moving downward. Now, we already know the time of free fall from our previous calculation. The initial velocity of the bolt, with respect to the ground, is equal to the velocity acquired by the elevator in the first 2 seconds. Using v equals u plus at, we can calculate the initial velocity of the bolt. Now, to calculate the displacement of the bolt with respect to the ground, we use s equals ut plus half at squared. Substituting the appropriate values, we can calculate the net displacement of the bolt during its motion. But remember, displacement and distance are not the same thing. The bolt first travels upward and then comes downward. Therefore, to calculate the total distance traveled by the bolt, we must calculate both parts separately. First, we calculate the maximum height reached by the bolt. At the highest point, the final velocity of the bolt becomes 0. So, using v squared equals u squared plus 2as, we can calculate the upward distance traveled by the bolt. The upward distance is u squared divided by 2g. Now, we add this upward distance to the downward distance traveled by the bolt. Using the values, elevator acceleration equals 1.2 meters per second squared, elevator height equals 2.7 meters, and the bolt is released after 2 seconds, we can substitute the values and obtain the final results. And that's how the same motion can be analyzed beautifully from 2 different reference frames. The elevator frame makes the free fall calculation simple, while the ground frame gives us a fascinating picture of the bolt moving upward, reaching a maximum height, and then coming back down. If you enjoyed this problem and want to master physics through problem solving, subscribe to Numericals Studio. Here, we make physics simple, visual, and interesting, one numerical at a time. Thank you so much for watching. Keep learning, keep solving, and I'll see you in the next problem.